Students, this is question number 7 and let me draw the figure. So we got two circles. So this is the first circle, okay, and then the second circle. All right, that will do. Let me complete the figure. The figure is not to scale. Okay, and then it is the approximate shape, and you have this point 0, or I would say O, C, B. This is 0.8 radians. This point is D. This point is A. This is 90 degrees. Now let me write the following. The diagram shows sector AOB, which is part of a circle. A circle with center O and radius 6 cm. Now O, or I would say AOB, so that means OB is equal to 6 units, right? And this will also mean, since O is the center, of AOB, this means OA will also be 6 units, is it not? So let me write that down, 6 units there. Fair enough. Now we have this information. The point C is on OB and AC is perpendicular to OB. The arc CD is part of a circle, with center O, and we are also given that D lies on OA. Okay, it's quite a bit. Now what are we asked to find? We are asked to find area of the shaded region. Find the area of the shaded region, right? So that is required. Now this is 90, AC is perpendicular, so this will also be 90. Now let me draw that part of the figure. Consider triangle AOC. So that triangle is going to be like this. Okay, this point is AOC. This is 90 degrees. Now this angle is 0.8. As I mentioned to you, O A is 6 units. Now what I'm going to do is I'm going to be utilizing Pythagoras. Okay, since angle C is 90 degree, we use Pythagoras. We use Pythagoras theorem. So what is that? OC squared plus AC squared is equal to OA squared. Now OA squared is 6 squared. AC squared I do not know. And then OC squared also I don't know. Okay. Now what I know is angle C is 90 degree. And what I wish to do is I would like to utilize the sine ratio. Okay, using sine theta as opposite side over hypotenuse side, we get AC divided by the hypotenuse side is OA. For theta is equal to 0.8, this means sine of 0.8 is equal to AC divided by OA, which is 6 units. So therefore AC is 6 times sine of 0.8. Now this is given as radians, right? So you can utilize your calculator and get that value. What I wish to do is I would like to convert this into degrees. Now you have degree, say for example you have degree measure, say 30 degrees, and you want to convert it into radians. So what do? We multiply it by pi over 180. This is degree measure to radians. Now I want to convert radian to degrees. So what would I do? I take the 0.8 and I multiply it by 180 over pi. But what is the value of pi here? Pi is 3.14 multiplied with 180. So because my calculator does not have that, that extra feature, so that's why I'm just adopting this measure. So 0.8 divided by 3.14, that is giving me this measure, and then to this I will multiply 180, and that would give me approximately 45.859. So I'm going to take it as 86 degrees. So what do I have here? I've got AC. So AC is equal to 6 times sine of 45.86 degrees. So let me find that out. Sine of 45.86. What is that equal to? And to this you multiply it by 6. So what do I get? 5.7196. So that becomes 10. So it's going to be 5.72. So AC is 5.72. Now having got AC, I can extract OC from here. So let me use this part of the space. So OC squared is now 6 squared minus AC squared. So 5.72. So 6 squared is 36 squared. 5.72 squared. So let me calculate 5.72 square. What is that? That is 36 minus 32.72. So 36 minus 32.72. What do we get? That is 3.28. But we need OC. So OC is equal to root of 3.28. So square root of 3.28. What is that equal to? That is 1.81. 1.81. That is the value. So therefore OC is 1.81. So 1.81 I have got. Now let me go back to the figure. So 1.81 is obtained. Now I need to get the area of the triangle, required shaded region, right? So the required area is area of the triangle, AOC. From that you subtract sector area. Sector area is what? Sector area is DOC, right? So we need to calculate that sector area. So how do you calculate area of the sector? Area of sector DOC is equal to half times r squared into theta. But what is the radius? We don't know the, or I would say we have found the radius OC. This is the radii, right? OC will be the value that we will utilize, because that is the point from O to C. So I'm going to substitute that. OC is 1.81. 1.81 squared. Theta, you substitute the value of theta in radian measure. 0.8 is the radian measure. Okay, 0.8. You substitute that. So this is going to be 1.81 square multiplied with 0.8. That is divided by 2. So that's going to be 1.31 square units. Now I need to get the area of the triangle, right? Area of triangle. So let me go back to the area of the triangle. So what is the area of the triangle? This is the right angle triangle. So half into the base into height. Now we have got AC 5.72. So 5.72 into 1.81. So area of triangle is half times base times height, which is half times, what is it, by base 1.81. 1.81 times height 5.72. So 1.81 times 5.72. That has to be divided by 2, and we get 5.177. I'm going to take it as 5.18 square units. So therefore the required area is equal to 5.18 minus 1.31. So 5.18 minus 1.31. What is that? It is 3.87 square units. Okay, so that is the shaded regions area.